Welcome to Electrostatics. Electrostatics is the study of charges at rest. So we just look at them kind of at an instant in time. We're assuming things are kind of held still, or at least some of it is held still. You're probably familiar with the term static electricity. It turns out that some materials, if you rub them against other materials, some have a tendency to lose their electrons, and some have the tendency to gain electrons. And there's something called a triboelectric series. If you look up triboelectric series, you can see what's really good at losing its electrons and what's really good at taking away electrons. If you mix them together, like one that's really good at losing and one that's really good at taking, then you'll build up a huge static charge. So my friend John will show me what's happening. He's good at taking electrons and this one there's enough voltage, like the electrons have enough energy because they're close enough together. And another very important thing about static electricity is like repels like and opposites attract. What that means is anything negative charged is repelled from everything else that's negative charged. Everything positively charged is repelled from anything else that's positively charged. And opposites attract, so positive attracts negative. So in this case, he's got all these electrons in them and they're going to spread out as much as possible. So to start off with, again, his shoe has a property that it likes to grab electrons. In the carpet has the property that it likes to take them away. By the way, this is not something that's really well understood in physics-wise, so this is one of the more mysterious things, this whole triboelectric series, triboelectric effect, and you kind of understand it for ages. Anyway, so notice these are spreading out as much as they can. They're getting as far as they can from each other. He's got a whole lot of extra negative charges. They don't want to be there, so they will get away as best they can. Now, normally it's really hard. There's a ton of resistance in the air between his finger and the doorknob, but as soon as it gets ionized, as soon as there's like a little spark that jumps, like we do it just enough, that strips electrons away from the air, and all of a sudden it conducts really well. So if we do a bit more, there'll be a little spark, and then it'll drain out. After you've statically shocked something, in general, you're not very charged anymore. Your hair might fall down if it was sticking up a bit. Yeah, so that's, by the way, the reason your hair sticks up is because generally you collect negative charge. So you've got all these extra electrons, and they try to get as far away from each other as possible, so they get into your hair. And then if all of your hairs are negative, like repels like, so all of your hairs are repelling each other, and so that's what makes it stick up and gets them far away. By the way, laundry, the dryer, the reason that works is you got a whole bunch of different materials. If you had all the same material in the dryer, it would have no static at all, because there'd be nothing with the tendency to give electrons more than anything else. But if you got a bunch of different materials in there all rubbing up, that means that some will gain electrons, some will lose them. And if you ever see anti-static balls or anything like that, or dryer sheets, all they do is they hold a little bit of water and allow the electricity to discharge. They allow, it's sort of a conducting, it's like putting a little bit of metal in there or something. Just lets the static electricity discharge, go from the negatively charged things to the positive. And that's all that's going on there. Let's talk a bit more about this static electricity. So we got a balloon here in a sweater. The balloon has a tendency to grab electrons. The sweater has the tendency to give them up. And the wall is not going to grab or lose them. So if we rub this against it, it picks up the electrons. Now the sweater is positively charged, the electrons are negatively charged. Notice opposites attract. But also, charged objects attract neutral objects. And here's why. So you wouldn't think so, because this is just as many positive charges as it has negative charges, so overall it's neutral. So you'd think there'd be just as much repulsion by the electrons as there is attraction by the positive things, but if we bring it closer, you'll see why charged objects attract neutral objects. So if we bring it a bit closer, notice the electrons move away, and so we've got a bunch of positively charged things that are closer than the negative charges. So even though there's an equal number of positive things as negative things, the negative things end up moving so that there's a net force of attraction. We've got to get it a little closer. There we are. So charged objects attract neutral objects. Now, one thing I want you to do is in your house, find hopefully a balloon. If you don't have a balloon, take pretty much any form of like plastic wrap that seems a little staticky, and just like rub it on a sweater or rub it on your hair if it's clean enough. Anyway, and then bring it to a stream of water. Like turn your tap on a little bit. The water is neutral, but it's very polar. So it has not a hard time switching, so one side of it is more strongly attracted than the other. So if you can get this charged objects and don't put it in the water, but get it close, it'll bend the water and it looks really cool. Anyway, so do that with a balloon or do that with some static things. If you get it wet, it's all over because then you discharge the object, but give that a try. Anyway, this has been a bit of an intro to electrostatics and the triboelectric effect. Basically rub things together. Some things like to grab electrons, some things try to lose them. Things with extra electrons are negative. Things with less electrons than the protons are positive. Charged objects attract neutral objects. Oh my goodness. All right. This is long enough. Thanks for listening, and try out that thing with the drip, not drip of water, but small stream of water in a balloon or plastic wrap or whatever you can find. Anyway, stay well and talk to you later.